Oops. Okay, I think we can start because we have 6 presentations, so the time will be short. So, ladies and gentlemen, welcome to this first session about linked data. As you probably know, we have 2 sessions. So we have one now, and the next one will be just after lunch. It's clear that linked data for Inspire is quite a hot topic. We had also 2 sessions last year, actually, and the number of examples of the use of linked data technology in Inspire is increasing. So what I would like to do is to try, at least after the second session, to do a kind of a wrap-up in order to understand the commonalities between the work done and that will be reported here, to verify whether we can work together to find a consistent way of using linked data in Inspire. Also because there are a number of initiatives now that plan to work on using semantic web technologies for geospatial data, like the joint W3C OGC workshop that just recently there is a draft published about the charter of this workshop. So this working group may do work that is very much interesting for us. I will kindly ask the speakers to stick to 15 minutes for the presentations and to give at least 5 minutes for questions. Again, we have 6 presentations, so we must stick to the time. So it's my pleasure to invite the first speaker, Carlo Cipolloni.
Good morning, everybody. I talk about the semantic aspect of the metadata catalog and geoportal of a geological survey of Italy. We take in consideration not only the link data or the link open data, but all the aspects that at the moment is in place inside the geoportal. This is our geoportal. It's a portal based on the Esri geoportal server 1.2.2. Probably in the next step we pass in the new version, but it's a natural migration of the data and of the metadata catalog. And then we have a viewer, a flagship viewer, that's also available to searching metadata inside the catalog. And then we talk a little bit in detail what we have implementing behind these 2 elements to searching metadata to increase the using semantic aspect in searching metadata. I need to explain before to go in detail on the semantic aspect that we have also implementing a different profile inside the metadata. So in some case we have implemented national standard metadata profile that is wider as an extension of Inspire metadata profile, and also we have implementing the One Geology Europe profile that is geological profile wider than not national, and including especially some aspect of the quality data, especially go in detail the sources how you obtain the data and all the information that you need to arrive to realize the data set. And also have a particular aspect, I talk about this profile because this profile is able to manage multilingual profile. We have developed a specific aspect also to have a metadata editor inside the geoportal to implementing this part of a profile. And later on I explain something that is strongly related with multilingual, and you understand why we need also to have a multilingual profile inside the the catalog. The main target of our presentation is an extension of the last year presentation, where we're presenting the fifth approach to have an ontology engine behind the GeoPortal. To searching metadata, we have developed ontology service based on GEMET, but also an ontology service based on the TIS. TIS is the Italian thesaurus for earth shines, a specific thesaurus that we have developed in Geological Survey in ISPRA to before index the library material, but also to improve the searching of a metadata inside the catalog. If you're looking in the lower part, you have a specific interface to asking in double language, Italian and English, because the new version of the TIS is an SCOS ontology, is able to searching specific concept. In the concept, you can see you have a double language prefer label, and this part is also then explained well, part of a framework of another project, and is now published as a link open data, so it's an allowed. The powerful of this searching is to, and this is representing the loud. This is now in the EMV Plus thesaurus framing infrastructure, so it's part of the loud, and the TIS is interlinking with the earth and another thesaurus, and is interlinking the GEMET. So all the three vocabulary thesaurus, sorry, is interlinked, so we can pass from a concept to another concept, like required link open data. And this is an example of some aspect of the TIS inside the Sparkle endpoint that at the moment is published by CNR IMATI, that is partner in the EMV Plus project. If you're looking the part of the servlet, you have the terms. You can writing the terms in Italian or in English language, but then you need to set up the language. You can defining if you want a response in the RDF file, or if you want the response in Lucene. Lucene is the engine that is behind the GeoPortals. So in this case, if you want XML, you have a RDF file, or otherwise you have a string with the ranking of relate terms in terms of broader, narrow, or relate terms to the main concept. And this you can see also also inside the listener you receive the double language base name. The implementation is based in a collaboration with the Esri Italy. Is based to have a multiple searching inside the ontology service. I said before that we have a GEMET ontology service, and we have TIS ontology service. So you can searching the terminology. This is the string to link the ontology service to GeoPortal. You see that GEMET is called like, and TIS is called TIST. So when you're searching characters, words, you can using Italian or English version, but you can also search in a single catalog or in a combination of the catalog. So in this case, you improve the quantity and the result of your searching inside the catalog. And I show you some example. If you're looking to our catalog and searching a lithotype, this is a lithotype, in some cases you not have any results. So you see thinking that you now have metadata. Really, if you go, oh sorry, I go too fast. If you look into the, okay, to the using of TIST, in this case we encoding TIST research, the result increase. So in this case you can improve your quality of research. In fact, you can using all the related terms to the TIST ontology. The same searching is possible to do with the viewer. So the viewer also is set up to using the TIST and GMET ontology service. In fact, if you're searching metadata about, for example, hydrogeology, you have two metadata, the red line represent the metadata elements, but if you're using also TIST one, you have more than two, and you have also another one. So you increase also in case when using the viewer your research. And then what we have also done, we have also implementing a Sparkle. At the moment, the GeoPortal is also able to use as a Sparkle endpoint to searching the metadata catalog. So you can performing a research using some query of Sparkle, and you obtain a result in terms of a metadata reference. And then also the TIST represent one of the metadata inside the catalog. So you can search in TIST inside the catalog, you can find the result of this catalog, and you can using the link open data that is related to the reference. But inside the geological survey, we have also implementing some ontology. The geological survey of all the geological survey in Europe, but also in the world, are using some vocabulary developed in the One Geology project, One Geology Europe project, but also in the CGI UGS, that is a body, international body, to manage geoscience terminology elements. So we have a lot of vocabulary to relate to the terms that we're using in the database, in the contents. So in this case, if you see a specific catalog, you see that you have a definition terms, for example, for environment of deposition, and then we're using this term to encoding in the WFS. This is an inspired geological in WFS encoding using the geological data model. And if you're using the contents of the vocabulary, you create a link data system of data. And if you have a client that is able to link this information, you have also the information inside the client. In conclusion, we're implementing the TIST ontology service to improve the quality and the quantity of the result, especially to the people that not exactly know what is in the catalog. So writing keywords and receive some result more than not using a simple keywords. And now I explained before that this is a part of the EM plus Tersaurus framework, so it's published as a link open data, so it's possible to reuse or to interlinking with the other vocabulary to increase also the interconnection. And then implement the ontology service to have a semantical harmonization of the contents and a real web semantic information when you're asking for the data, because when you're asking for the data is a link with the vocabulary, you have also the definition of vocabulary, and you increase the quality and in terms of readable elements associated to the data. But in conclusion, just one remarks or sentence. We have open data, but really we're not lacking open data in Geological Survey of Italy. We lack link open geodata because it's more related to the ancestral data. With the link open data or link open geodata, you relate the data to your data, so it's more transparent system also for the people that receive a replication of your data. So in this case, you can go back to the ancestral element, and you have all the path to be sure that the data is real or not real in terms of contents. That's it. some reference if you want.
Thank you. Are there any questions?
Would the technical solution be possible also with non-open data, with protected data?
We have protecting data. Not all our data is open data. At the moment, three parts of it, we have defining two different licensing at the Geological Survey of Italy. We have some data that is open by default, so we can providing as a open data or open link data. But at the moment, just Datasaurus is link open data. The other is the FS service with open default licensing, and then we have also data that is not responding to open licensing, but have common creative share alike no commercial licensing, because in some cases we are the official map agency, so our data is certified and used also in legal contests, so we want to maintain a reservation of data. So in this case we published just the FS with the licensing how to use this.
There is time also for another question. No? So thank you again, Carlo. So, we're now the second speaker, Iwaniak. The floor is yours.
Good morning, everybody. My name is Adam Iwaniak, and I have a pleasure to deliver a presentation under the title Publishing Metadata in Link Open Data Manner, Building the Bridge between Inspire and Web 3.0. This presentation I prepare with Iwona Kaczmarek, which is present today, and Jaromir and Marek. They are still implementing new version of this catalog services. I represent two organizations. One is University of Environmental and Life Sciences in Wrocław, where we think how it should work, and also private company where we implement this idea. It is the Wrocław Institute for Special Information and Artificial Intelligence. Before I start, I would like to show you my idea that today we have 2014 and we have a Samsung Galaxy 5. And 4 years ago, it was Samsung Galaxy 1, and there's a very big difference between them. I'm not pretty sure if you use it, but I see this difference. But do you think how it will work in 20 years? How our smartphone will look in 20 years? Why I asking? Because today is 2014, and we have a catalog services, and my question, how it will look like in 20 years? And it's good to remember that the idea which we implement today, they have 20 years. It's a very old one, in fact. We invent this idea and implement before the Google start, or just at the beginning, yes? So I think today we have a big problem with metadata and catalog services because we invented this idea, we tried to build this idea and implement it really 20 years ago. We live in different reality. So today we can discover such metadata for files like title, abstract, but in fact if you would like to find something more precisely like parcel, it's quite often difficult, maybe not always. But when I look how the metadata are implemented in Inspire, I think that is a beautiful story, how to complicate it, a simple problem, and increase complexity a lot. you see that we have ISO, I have nothing against, I strongly support standard 19115, but in fact in Inspire we collect 30 attributes, simply attributes, and the model for these simply attributes look like this one. Yes, it costs a lot. Our public administration, also me, costs a lot. In fact, in the end, it's difficult to find something. Yes, you can see that is the portal and the functionality of different, we implement this idea in different ways. So only, I think, sophisticated and professional user can use these portals to find something. For me, I'm not surprised because it's 20 years old idea, yes? And I think that is quite well implemented. But I think the problem of metadata, I heard it in Singapore in GSDA conference that metadata is not sexy. And is that true? They are not sexy. It's a really boring topic. Sorry for that, for my presentation. But I think what to do to make metadata more sexy, more interesting, more easy to use. Certainly inspires the process, is the way how we can heard at the beginning of the conference. I teach the SDI at my university and I run a lot of courses and make a survey. And I ask about metadata. At the end of the semester, I ask my student, try to find metadata about some city like Augustów or different city. All my students after the SDI course will make me crazy, use a Google. I spent half of the semester trying to teach them how implement metadata. Google in Poland is very common. And at the end of semester, all of them use a Google. Certainly that's my fault. I can't complain, but I noticed that also students I haven't teach, they also use a Google. All my friends use Google. It's something worse. I do that. So, and the way how use it, they search by any text. They use search, and more than user use a Google. So, I would like to. The key question is, how are the user? What are the user needs? In fact, how to search, integrate, process, and infer data. How to create sexy metadata. 2 years ago and a year ago, also in this conference, I mentioned that we can improve, like Carlo mentioned in previous presentation, that we build some thesaurus and we organize this thesaurus that way that we include in thesaurus all the application schema about the product which are searchable through our geoportal. So we can not only search for the keywords which are included in the metadata, but also we can use name of the feature, but also synonyms of the name of the feature, which are included in the application schema for the product we could be searched in GeoPortal. Similar solution is implemented also by GeoNetwork. I'm not pretty sure who did it first, but doesn't matter. You can see we use as cost standards. We have a preferred label, also alternative label. We have a different name for the people use different name, and it's quite difficult to find which one will be used. So we have alternative, and sometimes we have a misspelling. So we can use also in SCOS hidden label. That's quite common. We noticed that is quite common mistake. And so we have a GeoPortal implemented with this thesaurus. We called it intelligent catalog services or semantic catalog services. If we write the name of the feature, we can see products which are available in the metadata database. In catalog services, we can indicate which we are interested. We don't need to look through all this product. After that, we get a list of the metadata. And we see that it's published in HTML, in fact. But we certainly can see how it looks in, it is in HTML, but we can also see how it looks in XML or PDF. So we can publish metadata in human readable form in PDF.html, but what we try to do it now, is we try to publish metadata in machine-readable form, yes, in XML, and during the last time we start to talk about RDF and HTML with RDFA. So maybe I skip the slides because of the time, but RDF is quite common, and allow us to publish information in triple, subject, predicate, object. So if you look for the architecture of such solution, we can see web resources which publish on the web, but for all of these resources we can create metadata expressed in the triple. So we publish in different way, but we can collect in triple store and make endpoints, SPARQL endpoints. SPARQL is we can compare this language to SQL, which can allow us to ask about the information. We use a concept in the RDF, we use a concept and a relation. This concept and relation are defined in ontologies, also published on the web. So we can see how the metadata looks in XML and RDF. You can see that we use a Dublin core ontology. In fact, it is machine readable. I don't want to talk a lot more about metadata in RDF because Carlo mentioned about it, but the problem is still, the main problem is not still solved because you can't see this RDF from the Google. And this is my solution. So it is my idea, it was our idea. So we tried to build a new catalog services, and our assumption is that metadata should be available for web search engine. Also, we would like to link different resources like Gemet, GeoNames, Wikipedia. But the main question is, if someone looking for metadata, in fact, the person look also for data. So we also should improve access to data, not only metadata. And so we say how to do that. And we say the open software is a fantastic solution. And also, who knows where to find the metadata portal? It's not quite easy. Yes? If we know the concept, we can certainly find the metadata portal. But if not, people don't do that because they don't know that it exists. So I think that it's also worth to facilitating searching of metadata, access to metadata portal. So our solution is the use RDFA. It is also the new language which enable embedding RDF triples, subject, predicate, object, into HTML documents. And this subject predicate could be a metadata, but what is the most important, that also processor can extract this RDF triples from this HTML. So when we look, we can see that is such HTML with RDF data look in a normal way, but when we if we would like to see the source of this document, we can see that is metadata included. Here is this a part, certainly there is a long document. So the architecture is a little bit different. We also add we add HTML with RDF, and that case we can transform, yes, we can add different resources, but we can transform this HTML to RDF store and have application which can ask about data. But that case, another look for this architecture, we can see if we publish our metadata in HTML with RDF, we can not only possibility to build RDF repository, but it's also in some case indexed by the Google search engine. What we look like. And how it works, we implement in Województwo of Podlasie in Poland. It is about more than 6,000 metadata records. Certainly one of the biggest problem that Google didn't know the area we are looking for. So we use the name of the city. So if you write metadata Dobrowody is name of the city, we can see the first two are our metadata, in fact. Look this way. But we also have a link to the Gemet and to the Gemet when we have a link, also the Inspire. So we can see that we use, sorry, but it's in Polish, it's rzeźba terenu, but in Gemet is already in English. But we can also have a connection link to the Go names and try to find where it is. But, okay. And if you here, you have also link to the catalog services where you have more metadata. So when you click here, you go to the metadata portal. And here you have a big possibility to find everything what you need. So you start from the web page and Google, at the end you finish at the Geo portal if you need it. And we have a second version also a little more complicated and more metadata. We built it for the services, WMS services. And here, if you have services, the data are available and you have a cookies project. When you click to Google project, you download a project in cookies and you can run and see how this WMS look like. So you have much easier access to the data. In fact, not data, but services. So one of the biggest problem here is how we locate our metadata, and we have just the entities. So we use, as I mentioned, Go names, but also certainly we use ontology, Dublin Core ontology on improvement of it to indicate the bounding box. I hope that in future Google take into account and also allow us to find by coordinates. And the conclusion, when we use RDFA XML HTML file with RDFA, we can access metadata by search engine, with easier access to data, we have a relation to other resources, easier access to catalog services, but in some fact we also make a mess in the web, because when we start publish thousands of the metadata records, maybe, and all of them start with the topographic maps, could be the problem. But we can see nowadays we have 6,000 published on the web. And also we noticed that the Google changed the idea how we have indexing and ranking of the page. So we as third party, and we strongly depend on it. And I don't mention about it at all, but I think one of the most and the biggest problem should be mentioned is that we should change ID for metadata and start to use URI. That is very, very important, and improve access to data very much, also managing it. But the time was too short, so I didn't mention. Thank you very much.
Thanks a lot, Adam. A very interesting presentation. And fortunately, we had the pleasure of having here Pilacher from WTC, also at Parson from Google. So they will be able to
yes,
reply to your questions. So, Phil, you have an answer, right? Question, sorry.
Just very quickly, because I know time is tight. Phil Archer, Data Activity Lead, W3C. You've done a lot of stuff there about how people use Google to find stuff, and showed us how it works in an extremely interesting presentation. Thank you very much. There is a mechanism by which you can help Google and the other competitor search engines make it easier for you to find your stuff. And it's called schema.org, which is Yandex, Google, Yahoo.
We use schema.org a lot.
Okay. If you want to get your metadata terms into schema.org, you can go through a process. There's a public mailing list that's run in our space, and if you propose new terms and show it being used, then the schema.org partners can then decide if they want to take it in. It's an almost open process. It's a very open process for you to propose it, and if you want to increase the number of geospatial relevant metadata terms that the search engines actively look for, that's the mechanism. Public vocabs at w3.org is the place to do it, and the only bit of the process that isn't quite open is when they finally say yes or no, but it's a pretty open process, and we're happy to support it.
Thank you very much. We did it, in fact, after the conversation in Leuven a year ago about how to improve, and we were taught to use a schema.org. That's, in fact, we use it.
Any other questions?
Peter Paslow, Ordnance Survey. I do agree that making your metadata available via web search engines is much more of this decade. So I think that's a great way to go. Did you consider making the geometry in the metadata, even if it's only a bounding box, into a KML file? Because we found that actually sort of map enables the Google search. I don't know if it works for competing search engines or not. Did you try that?
In fact, not. We make a lot of experiment and try to improve, but I think that is a very good idea. Thank you very much, and we next conference probably show how it works.
Other questions? Okay. No, would like just to add one thing. There is work underway for the representation in RDF of inspired metadata, and using a profile defined inside the ISA program of the European Commission. And I mean, we have several examples of people implementing Inspire also providing access to the metadata in RDF. So this work was also meant to have a common representation to make also the RDF representation of Inspire metadata as interoperable. So this is something that we would be very happy to share. So okay, if you are really interested.
Certainly we have to find today our own way, but it will be much easier and better if you have a common standard and we can all of us can use the same standard. Certainly, yes. Thank you for
Thanks again, Adam. Okay, the third speaker. We have to check the order. Sorry. So, Tomasz.
Good morning, everybody. Thank you, Andrea, for introducing. I will be not so technical because you already know everything is about linking data from my previous colleagues, and I will give you some concepts which we prepare for the crisis management in Polish Geological Institute. And the presentation was prepared by a team of Grzegorz Ryżyński and Adam Iwaniak. You already know him from the brilliant presentation just before me. And first, I would like to give you some general statement. What I noticed on the geospatial conferences, people mostly work on what is on a surface, and it's normal. And on the other hand, a lot of presenters try to convince the audience that their domain is the most important. I will not follow that. I will just show you that in some cases, what is under our feet could be important. But before I go to the main point, I would like to say a few words about Polish Geological Institute, which I represent. It is the institute with nearly 100 history, and the main task is firstly evaluation of the national mineral potential of the resources. Secondly, some groundwater issues with the groundwater protection and monitoring. Then we use our knowledge for giving the information for the for the construction of the safe infrastructure. Of course, we do the geological and environmental mapping. Moreover, we manage the geohazards, which will be the main topic for today. And finally, we are the custodian of the huge resources of geoinformation. That's the real situation, and it was not done by the city service during the night. It's the natural process, and sometimes it happens. So it's very difficult to predict it. On the other hand, we need the right information to save the infrastructure and avoid casualties. And our job is to help assess the disaster or risk associated with the extreme geohazard. And on the other hand, mitigate of possible threats for society. And I would like to give you some example about the information, but always those information are afterwards. We have a lot of information when the crisis happened. But our job is to secure people and give the information before disaster strike. So we prepared the concept of the Geohazard Information Center. And now it's on the feasibilities study, so it's just a concept, but quite mature. So a few words about the crisis management in Poland is divided into fourth level, probably as in many countries. So in every point we have the management center. So that's the point where we would like to deliver the geohazard information. In Poland, we have the main government center of security, which publish the report like there for the public, and of course, geohazard and geoinformation is about hazards. It's just a small part, and we would like to deliver that information. But what is important? People don't like scientific papers, so that information, as you can see, should be very simple, just to the point to know stay or escape. That's what should be given. And in our concept, we prepare it on three main pillars. The first one is coordination the geohazard in one point. Then we use our knowledge and expertises. And in the end, it's a communication which is very important to deliver the information. That's the main pillars, but it's something in behind. So we have this center based on those pillars. The first one is dispatch desk, which is the communication one. Responsible for the knowledge is the expert system, and in the end, video or teleconference module for the communication. We divided the system into two main issues. The first one is general reports, standard reports based on that data repository. But in some case we need more precise information, and then we of course use the domain databases and prepare some expertise. Those expertise are more suitable for some clients, and that's the general concept. But I would like to give you some more detail. First of all, that dispatch desk is a kind of central point, contacting with the stakeholders and giving them the non-standard reports and expertise. Then we have the web map portal with maps, prognosis, analysis. Of course, we have the reports, as I mentioned before, and those reports are the part of the central report application. And those both elements are public available. So that's the elements of the system. But in some cases, we not only can give the consultation by the dispatch center, but also we need, as I mentioned, much more precise information. So we do non-standard reports, then some investigation in the field, but sometimes we need also expertise. And it's built like that. Then every next level is enlarge the previous one. Of course, as I mentioned, we have the teleconference center to disseminate the information and support the crisis management when it happens. And here is the system architecture. It's divided in some main points. That's the core one. The red one is the dispatch desk. Here is the teleconference system. The whole core system is connected to external PGI system, but also we have some connection for the external points as a central application. Here you can find the business intelligence for the system and the repositories, which are divided into the internal one with our data, and also the second one with the external data, which are coming by different sources from our partners. As you can imagine, our databases are diffuse, and sometimes it's very difficult to find the information. So we introduce to the system some algorithms which find for the precise geohazard, find the information and prepare the special workflow to deliver the data. We also use some reference data from other sources, and on the top we have the queries, which help us to find them the answer for the given question. For example, we can give the information about all landslides in one district, or even we can give the landslides in a buffer of the road, which is important from some VIP people, because on a daily basis we are asked by the national government also to deliver that kind of information. So it's not only in case of crisis, but to predict some crisis situation as well. And finally, we are close to the main point, which is linking data. As I said, I just give the general information about that, because you know from Carlo and Adam there's a lot of the technical issues. So we decided to use linking data internally to find more information for the experts, because for the standard reports it's quite easy. We have the algorithm, and it's easy to follow the way, but for the experts, where they need some more information, it's difficult. So when we give them metadata for many our resources, then we can easily to deliver to experts some more information. But also, of course, also we can connect those data to the external world by the web. Of course, we use the standard vocabularies and the ontologies, the OWL and devs, as Adam mentioned before, and that linking open data support our main concept. We have look at it on the details in that slide. So there is our resources and the external resources as well. By the ontologies, we prepare the triple store. We connect to the LOD cloud outside, and then by the Sparkle endpoint, we can connect to our application, but also our application by the algorithm can go directly to the databases. So that's the main concept to support the system. And now I would like to sum up. Once again, we prepared the concept about system supporting decision makers with the crisis situation with the geohazard information. We can use those information for the standard reports for the central, national central application. Also, that way we will be able to prepare the client-oriented information right in time. The algorithm will be very important to prepare the right reports. And in the end, finally, we use the LOD as a tool delivering wide range of information from the internal databases, but also connect us to the external web information in different sources. So I appreciate your being here, and thank you for your attention.
Thanks a lot. Tomasz, you also saved 6 minutes, by the way, so thanks very much. So are there any questions?
Hello, Thomas. Benoit Borens from the InGeoCross project. Just a question about linking your data with others' data. What kind of, because you speak about delivering your data to interested parties, but what kind of other linked open data you could try to include also to link with your own data? From which sources did you have? Do you have some ideas about? I don't know, about Earth observation data or things like that. Do you have already some examples of linked data that you would like to do? Okay,
so of course, as I said, it's just a concept just now, and we're waiting for the funds, and I hope that on the next conference I will give you the presentations about the result. But we've prepared some potential sources, and of course would like to be Inspire compliant, so would like to be connected to the Inspire vocabularies. Also the vocabularies is about which introduced Carlo with the geological data, so it's a vast resources. I think that it's a lot of sources, and we'll be working on them in the future.
Any other questions? Okay, thanks a lot, Tomasz.
So, hello to all, good morning, and thank you very much. I'm here on behalf of my current project, SmartOpenData. This is an FP7 project, and I'm not going to repeat some information that I explained 2 days ago, this Tuesday, because we also offer a workshop. But anyway, there is some information that I could show you. For more general information, please visit our webpage, smartopendata.eu, and also we have a Twitter profile and LinkedIn profile, so you can also use these tools in order to know more about the project. One of the main objectives of the project is to create bridge between two different groups: the people who know about geospatial data from the SPI, like the SPI community, and the people who know about link open data. This is one of the main objectives of the project. So this is some information about the consortium, but all information is in the web page. So I'm going to present what task is currently being developed in the Spanish pilot of this project. We have oriented the task that we want to develop in order to answer simple questions. So the simple question that the pilot has to answer, they are these two ones. What are the best species that a farmer could grow in his parcel, and where are the best seeds for more suitable for example, the soil condition, the physical condition, soil, temperature, things like that. This is a general schema about the data that we are using. Traxa, my company, is a public. It's not a public administration, but it's a public body. So consequently, we are not the owner of the data, but we are the keeper of a huge amount of data. So the first step, the first task that we are carrying out currently is first of them. Harmonizing or doing the INSPIRE compliant process, but we can wait we can waste more time because this project is very short, and in this step we are avoiding this main line, and we are using raw data in order to develop or to create linked data. Just one comment, for example, our data are not, all of them are not open, but this is one of the objectives of the pilot, that eventually it will offer a very big amount of data that currently are published in web page, but they are not easy to find and they are not easy to use. At the end of the project, we were also linked, and there is other kind of data that could be useful, and they are very important currently, but this kind of data could be hardly considered big data also. It's a shame because they are very huge, we have a very big variety of data, but they doesn't change quickly. They are about farming, about trees, each other kind of rhythm, they doesn't change quickly. This is I'm going to speak about why are you. In the next slide, I'm going to explain the process and how INSPIRE is involved in this project. This is one of the things that we are currently doing now. For example, the information about farm cadastre is not yet INSPIRE adapted. So this is one of the things that is not directly carrying out by the project, but the project will use this inspired data. There are several general common information about the things that we can do without problem. For example, a chain of reference system. This is trivial. This is question trivial. Also, we are using all the information about the metadata attributes. This is the information that we are using in order to develop the linked data. This is one of the main ideas that I want to transmit. We are using data that they are inspired compliant, but also we are using data as they are in order to develop this linked data architecture. One of the conclusions or one of the results that we want to obtain from the project is find out statistics about this process, which kind of data runs better, inspired or not inspired. This is one thing that we want to research. The main information that we are using is basically or mainly about these three themes, three inspired themes: biographic regions, habitats and biotopes, and species distribution. And also, we are using very intensively other kind of database that, for example, is not public. The people can't. It's not open for citizens. This is one of the lists of the attributes that we are using. For example, after that, when we see the information about the farming cadastre, I will mention that there are references to owning of property that, of course, they are not open to general public. For this process of adaptation to inspire, we are partners of Esri, and we are using ArcGIS4 Inspire. And this is the model that we are currently using. This is some technical information about the attributes that finally we are going to use. This is our data model, and I would want to mention that the red tables are geometry, they are topological information. The blue tables are related with Annex 1, and green tables are related with Annex 3. For example, this project, this is very interesting for my company and for the developing team, because all the operational, the topological information that are directly related with the red tables are trivial, and this is a thing that we have no problem with them. So we want to use the technology of linked open data in order to extract new interesting information from the blue tables and the green tables. This is a generic overview of the data model. And for example, we are using also, we are keeper of the SIGPAC information, land parcel information system. PAC is the acronym for Common Agriculture Policy, so we have all the information about all the farms, all the parcels in Spain. Of course, there is information about the owners, and there is a geometry information that currently is stored in a private format, but also we have studied how to, and for example, I remember that 6 years ago we began to use that well-known text in order to store the geometries, but we don't use this format due to technical reasons. But we could use again this format without any problem. there are several information that about the land parcel information system, about the attributes that we are going to use. And for example, currently this work is my workmates are currently working on this, the transformation from the land parcel information system to Inspire compliant datasets. There is an interesting question that could be a problem. For example, the inspired term is agricultural parcel shall mean a continuous area of land on which a single crop. There are 2 points in this definition that has problem for us. For example, continuous area. We have, I don't know, but maybe all of them, they are multi-polygon, so they are not, obviously, they are not continuous. And again, usually there is not a single crop inside a parcel. So this is these 2 points we have to work on them. Which is the process of linking data? What we are going to do with our raw data after inspire them? We have to discover relation, we have to harmonize them, and after that linked. As you remember the schema that we have seen previously, we need also a triple store, things like that. And if you remember the 2 main questions that that this pilot aims to answer, currently we realize that this kind of answer could be solved just using traditional relational database technology. Why we want to use linked data? Because we know that there are more complex questions that could be answered, and they are going to be very useful for farmers. Indeed, one of the contractual responsibilities of the project, it at least involves 5 small or medium enterprise in the project. And currently in the Spanish pilot we have 2 of them, and another one is very interested. Why linked data is necessary? Because the reality is complex. We have huge amount of data about climatology, kind of crops, planimetry, and there are a lot of information that could be useful, but it's not possible to. For example, I'm currently working in the information about the forest inventory, and it's not easy to work with this. For example, I have to work with a document of 250 pages about tables, auxiliary tables, complementary tables, and it's not easy to find the information inside this kind of databases. So this is one of the first results of the project about using the simple model about the forestry invent, and for example, using this information, it's easy to find information about which is the more suitable species to grow in one parcel, which kind of density is more suitable for this parcel, and so on. This is the kind of question that we want to see answered in this project. And I have to end, and for example, there are several conclusions, but I want to point out that is Inspire a good starting point to link data? And of course the answer is yes, but I have to use also data that are not Inspire compliant. And one of the results that I want to offer in this pilot is to compare these results in order to show a statistical result. So thank you very much. And if you have questions, thank you.
Are there any questions? No? Okay. Thank you, Jesus.
Thank you very much.
Good morning. I'm here to present a work. Actually, it is a final dissertation, final thesis dissertation for my end of studies at University of Alcalá de Henares, and it's related with cadastral linked data according to SPIRE. And at SPIRE, cadastral parcel is in Annex 1, which means it's really important, and it's a basis for environmental policies and planning. And for every country, it's really important to have a cadastre. It is the basis for land tenure and or land tax collection. So it's countries has cadastral for many years. And it's the geographical unit where the property has its impact on the territory. Yeah, and we are going to. This is a work in progress project because some points, the end points of the project are being developed and are not finished. And what we are going to do, what we are doing is taking the data from the Cadastral office in Spain, which are mainly two types. We have an old bunch of shapefiles which come from the Cadastral office, and they have a lot of layers there. And another one that it's pretty new, and they have been offering for not very much time, and it's a GML, and it's inspired compliance. And they have been serving it as with an ATOM technology. And we have been using both. They are both the same, mostly the same. Yeah, they are the same data, but not in the same way and not with the same attributes or geometries. So what we are going to do is using those files and using two standards, the Inspire Cadastral Parcel specification and the ISO 19152. Which is the LADM model proposed by the Federation International of Surveyors, and involving that, making models and linking them to more knowledge bases or data. All of this through best practices exposed by linked data. Yeah, this is the flow chart we are using, and the two last points are being work in progress. They are not done yet. And we start with the specifications of the data. Then we have made the models. Then we have generated the RDF. Then the links, and publication and exploitation are being developed yet. In the specifications, we have to say that we have mainly used the Inspire specifications for cadastral parcel and the LADM mode specification, which has been very useful because they have also the ontology on their web page, in Delft University page. and we have the data we have used, that's the files, the GML and the shape files about cadastral parcels and cadastral boundaries as Inspire asked for, and then the shape files that the Spanish Cadastral Office used since many years ago. The geometries, yeah, the geometries are those files, the GML file and the shape file. The models, some of the models as linked data proposed are being reused, and some of them has been developed from nothing. And it has been very useful, the LADM ontology model proposed by the University of Delft, and then we have connected it to Inspire through some developments made in Protege software as OWL files. It's important to say also that involving these models, for example, the LADM model ontology is not, the scope is not the same as Inspire. The scope of Inspire is planning and environmental policies. And the scope of LADM is much bigger, and it involves parties and policies and loyal attributes. So we are only focusing on the spatial package that LADM file has. But as we put the data in that way, some data involving planning or involving loyalties can be connected to it. Yeah, the methodology involving the ontologies, we have tried to make a network of ontologies. So having several ontologies, reusing them or making them, we have built a network ontology, and the methodology for building that ontology network it's called NEON, and it's been proposed by Suárez Figueroa at the University of Politécnica de Madrid. The third step in the flowchart is the RDF generation, and we have generated two kinds of RDF, one from the GML and another one from the shapefile. We have used some libraries, and in this case, for example, the GML file has been transformed to RDF using the geometry to RDF library. And then for the shapefile, we have used the shape to RDF library. Yeah, once we have the RDF and we have the URIs for the elements. For example, the URI for the element there and the Spanish cadastral data, we have a cadastral parcel, and in this case it's one urban cadastral parcel. We have tried to link that with more information, and the information here, for example, is we have the cadastral parcel, and we have tried to connect it with DBpedia and geolinked data. Geolinked data is a project guided by engineering ontology group from the Polytechnic University of Madrid, and they are converting most of the data sets in the Geographic Institute of Spain to linked data. Yeah, and this part, it's work in progress, and we are using for publishing, we are using Parliament as a triple store, because Parliament meets really good with GeoSparkle, and we can make special queries on that. Yeah, then the exploitation of the data, it's going to be a WMS, but with a Sparkle point for building queries and making special queries to meet data. Yeah, as main results in this work, we have built the ontology network using the LADM ISO profile, which is we think it's very useful not only for us, but for many people that are related with laws or any other package involving LADM, because we can extract a lot of knowledge from that data. And also for the inspired cadastral specifications. Yeah, and after having those linked data, we have enriched the data with DBpedia and geolinking data. And as future work, we are just generating the and publishing the linked data and representing the linked data as geographical objects in a WMS, and with the possibility of accessing a GeoSparkle point and making queries. Yeah, thanks very much for your attention, and that's all.
Are there any questions? May I ask you a question? It's about the work you did for generating the ontology from the ISO model. Yeah. According to you, which are the issues? Because we have already some examples of trying to create RDF vocabularies or all ontology from ISO or OGC standards. So which are the issues that you were facing?
Actually, it wasn't that difficult because, for example, for the LADM model, we have downloaded it directly from Delft University. Microphone?
Oh, sorry.
They have the model already in the Delft University. So, and the guy that made the model is one of the guys involved in making the ISO. So we already had it. We had some problems because the LADM model is built on 4 packages, and one of them is the one we need, which is the spatial package. So the only problems we had is making an ontology between the inspired and that spatial package. That's it.
No questions? Thank you. Questo giusto? Sì.
Thank you, Andrea. So I will make a presentation that is not technical. I'm Massimo Zotti from Planetech Italia. You probably know Planetech because it's the company that is in charge of the development of the new inspired geoportal for the European Commission. And also, because we are talking about linked open data, you maybe have heard about Catalogue, that is a tool we developed to transform web feature services in RDF languages. We got a prize for that I think this evening at the gala dinner we will be awarded the SME Spire prize for the challenge. So, but I'm not going to talk to you about Catalogue, because we already presented that. We're full of technical information, but I'm talking about a business model, because I want to explain how Inspire, Copernicus, Earth observation data, linked open data can help companies, the industry, to make business, and also to support the governance of our local authorities. So I'm going to talk about the big availability of Earth observation data. I'm talking about satellite data, but also aerial photos, data collected from UAVs. You know that nowadays there is a huge amount of data available, and it's going to increase more and more, because in the framework of the Copernicus program, this is the biggest European program for the environmental monitoring, there will be a constellation of satellites that will be launched. Sentinel-1 is the first, 2 months ago it was launched. There will be other satellites coming that will provide the Earth observation data with a sort of open and free data policy to the European member states. From those data, we can extract information. So from data, we get information, the so-called value-added products that can be ortho images, but also information about the buildings, roads, land use, and some interesting information like the impermeabilization of the soil. We call this the sealing, so the part of the soil that cannot be penetrated by the water. We need those data to be produced as in standard format. This is why we talk about this here. I'm talking about sealing, but also about forest fire information, about flooding. Why it's important to have this information in standard format? Because this way we can compare the data, analyze the data, in order to get not only data, not only information, but knowledge. We really need to understand what is the quantity of soil loss today with reference to last year, with reference to 5 years ago, in order to support the governance of our territory. To calculate this information, now we can use open data. So we have satellite open data, we have other ancillary open data, but of course the problem is that very often the format, the structure of those data is not easy to manage. And so we have the problem of dealing with this data. But we also know that in the geospatial field, Inspire gives us a good support because of the standardization of the data models and so on. So, where do I want to go? For a company like us, like Planetech, it's very important to have open data. It's also very important to have a standardized data model, because this way we can respond to the big data problem with not a traditional manual analysis of the data, but we can go through the machine-to-machine processing of the data. In order to support the machine-to-machine analysis and processing of data, we need linked open data. And here we are. So what we are doing now, we are in the process of establishing an infrastructure. We call it the Data Fusion Center. We are doing this for local authorities in Italy, where we access linked open data, and at the same time we produce linked open data, so that the Data Fusion Center is a brokering system where the users can found and access not only the maps, the data, not only the information, but the knowledge. they can connect to the linked open data cloud, but they can also simply access to a dashboard where they just find the information they need, the knowledge they need about what's going on their on the area of interest for the governance of their territory. This is a screenshot of the user interface of the dashboard, where the users can have quickly statistical information, metrics, indicators about the soil loss or the water quality, or about floodings. So what I want the reason for presenting this is the importance of the standardization of the data that we need as a company to produce information, to manage this information in an automatic way with the machine-to-machine processes. The importance of having this information available as linked open data, and that involves the availability of common ontologies. So it's very important to count on the work that is done at the European level to define common and standard ontologies for the data that we need in order to automatically process data and provide this kind of results, those information, this knowledge to our customers. I'm done. Thank you. Any questions?
Just, I don't know if questions or remarks. Be careful when you propose a model where the analysis is machine-to-machine analysis, because sometimes machine is machine, not understanding exactly all the process, the natural process. So it's in terms of, for example, soil losing. Our organization in Italy is responsible for soil consumption, and sometimes the machine-to-machine read system make some errors because not taking account some evaluation parameters. So it's good. I remark this. It's good right sense to propose linked data, but be careful to propose an automatic, a full automatic system in this case, especially in the analysis terms. If you look into the process of data, well, but not in terms of analysis. I mean.
Any other questions, comments? No? Okay, thanks a lot, Massimo. So this closes the first session. Okay, quickly wrapping up. We are still having a lot of discussion inside the Inspire community whether we should use or not linked data in Inspire, which are the advantages, whether linked data is able to address all the requirements that we have. It's a good discussion. It's important to understand better how linked data can address requirements in Inspire. But the point is that we have already a number of examples where we are already using linked data in Inspire. So probably one of the questions we should also answer is, as an Inspire community, should we coordinate better our efforts, or this may help the implementation of linked data and simplifying things? It is, if I can make a comparison with respect to what was presented last year. Last year were very interesting presentations, but one of the common denominators was that everybody was doing not the same things, so they were addressing different issues, but the point is that they're doing work in total isolation. With respect to last year, I noticed, also looking at the presentation that we're going to have in the second session, that there is more coordination because, for instance, the reuse of the ISO ontology of the University of Delft, for instance. And we have already example of projects trying to reuse work done by the other projects. We have results, for instance, from the InGeo Clouds project. Benoit was here talking about this. GeoNode, there's another project just published, a report about the full linked data implementation of linked data inside the Inspire infrastructure. So Massimo just pointed out the issues of having, let's say, standardized Inspire linked data or the vocabularies. There is also work underway inside one of the actions of the ISA program related to Inspire Arena on RDF vocabularies and persistent identifiers for Inspire and location information. So one of the things I would like to discuss in the second session when wrapping up is whether we may think of setting up a, let's say, community working group inside Inspire, an informal one, just to share results, ideas, and to better understand maybe what is needed in order to simplify the implementation of linked data inside, or let's say on top of Inspire. It's also a problem of sustainability, actually. So thank you very much. I hope to see you also during the second session. So now we can go to lunch. Thanks a lot.